Okay, solar energy. Most of our resources, energy, originates in the sun when it comes to energy resources. Two of them we talked about earlier this week. The energy source originates from the sun. What two were those? Or which one was not, perhaps? Anybody?
Was that we did the free response question on?
Well, we talked about that with solar power, but right now I'm talking about what we discussed in lecture. We talked about three types of energy resources. What were they? Anybody? What's one of them? Yeah. We haven't talked about wind yet.
Nuclear. Yeah.
Nuclear, yeah. That's the one that's not from the sun. So what else did we talk about? Yes, Harley. Hydroelectricity, right? And what else? Really? Fossil fuels. Yeah. I have no idea what kind of sound a Tyrannosaurus makes, so. Harley, can you tell me why the hydroelectric that you mentioned how's that powered by the sun? Isn't it water? It is? The energy of hydroelectricity actually comes from the sun. Or anybody, if Harley, you want to pass it off. Okay, that's fine. It's kind of tough. Any ideas? Anybody?
Well, the sun causes the wind to blow and the water to flow.
Alright, well, no, actually, you're right. The sun does cause the wind to blow. So that shows us that wind energy, which we haven't talked about yet, but thanks for, maybe you're psychic or something, you're, remembering ahead. But that is the actual original energy from wind power comes from the sun, because that's why we have wind, because of the uneven heating of the atmosphere, as you know. The hydroelectric power works on the movement of water, right? It's any kind of water? Can you get it from the ocean?
River flow.
Yeah, you need a flowing river, right? Which means you need a change in what?
Current.
Well, elevation. Elevation. So in other words, for example, we don't really use hydroelectric power in Florida, even though we do have rivers. But our rivers don't really do what? As much. Enough. They don't flow enough. There's not a powerful enough flow from those rivers. To get that, you need that water to start high and making its way low. The higher it is, the more energy it has. It's called the energy of position. Just like if I were to take a rock and hold it like this far over Boomy's head and drop it on her, it wouldn't hurt her too much.
Why would you drop a rock?
Yeah. But then if I were to go to Maddie and get all the way up in the ceiling and drop it from a greater height, then that would impart more energy and do more damage. And then if we go out to the stadium and I was to drop one on Jack's head from up there, it could potentially kill him. So we'll test that experiment out at a later date. But that is because, where did the energy for those events come from? Where'd that come from? Yeah, Lindsay. Well, gravity is that's a force that propels it. Gravity is actually not a source of energy. It came from me, because I had to lift that rock up higher, or if I were to carry it up the stadium, I had to put energy in it, which you could even say eventually that came from the sun, because I got my energy from what? The food I ate, which got its energy from? The sun. Okay. Fossil fuels we know, right? Because fossil fuels, once living organisms, millions of years ago, they absorbed energy from the sun. They also got some added energy into them from the force of gravity of the earth. So gravity can impart a force. Gravity itself is not an energy form, but the action of gravity on objects can impart energy into something. And so, point being is we really have a lot of different energy resources that actually at one point got their energy from the sun. But when we talk about solar energy, we're referring to a direct usage of the sunlight that's hitting us right at this point in time, right? So we can use that energy in two ways. One of which is if it is absorbed as, technically that answer is right, group 8, so I'm going to go ahead and give you the point for it. But what I was looking for here is more of a thermal usage. And in other words, the sun, of course, heats things up. And if you have a need for heat, such as in a building or hot water or whatever, then you can utilize the heat energy from the sun and use that as an energy resource. So that's a thermal absorption. The other one is using what's known as a photovoltaic cell, commonly called a solar cell, so I'll give you the credit for that as well. But you do need to know the technical term because it's very descriptive.
What is it called?
I'm going to write it down. Photovoltaic.
From the previous one,
So photo meaning,
Like photosynthesis.
yeah, but what does photo mean? What's the prefix mean?
Light.
Light. And voltaic is electricity, basically, or electrical current. So photovoltaic. So that is a device that converts solar energy, sunlight, directly into electricity. Okay? Out of those two, absorption is the most efficient. Unfortunately, photovoltaic cells are still fairly inefficient. I think the maximum we've gotten out of them so far is about 30% of what is put into it power-wise. As far as absorption being used, there's two ways in which you can do that. Active absorption is where you have what we call solar collectors. And this is one you may have seen if you've seen the big black plastic, look like tarps, kind of, that are on people's roofs. You ever seen those?
Yeah.
You might have maybe a solar pool heater or know of somebody has a solar pool heater.
I've seen them
That's
before.
typically what they are. And that is collecting, that black plastic mat thing, that tarp thing, is collecting energy. It's a collector. And then water is circulated through that. And so that water is your transfer medium. As a matter of fact, usually that's the transfer medium. That's the stuff that you transfer that energy with. Sometimes you use antifreeze, but most of the time it's water. Okay. Commonly used for pool heaters. But you can also use it to heat your water. Mr. Creech, as a matter of fact, has a solar water heater that he uses to heat his water for his house. The other way to utilize solar energy is passive, and that actually means that it's not really actively doing something. Whereas in this, you're pumping water up to the collector, it's coming back down, you're utilizing that way. This is all about the design. So in other words, it is building, when you make a building, that you design and build it in such a way that it will get to increase, yes, that's fine. Technically, we're going to go with maximize. So it'll get as much, if it's in a cold area where you need to heat that building, it will do as much of that job as possible of heating that building by using that sunlight. By orienting it, clearing away vegetation, whatever else it is, so that during the winter, it's going to absorb and keep as much of the sun's energy as possible. Now, ironically, I think it's ironic, it actually also applies to shading that same facility or another facility that is in a hot zone and that you want to keep cool during the summer. So even though that it's hard to, you're actually avoiding or reducing the sun's impact in that particular situation, but that's also considered to be part of passive solar design. Either way, it helps to reduce your amount of energy that you need to get from a more standard type power source by doing it that way. So those are that's the absorption, the two types of absorption, ways of using them, active and passive. Okay, any questions about that? All right, solar energy, that's good stuff, right? Must be high quality, right?
Yeah.
No, it's low quality. Low quality. That does not mean it's a bad energy source. As a matter of fact, it's the most environmentalists think it's the ideal type of energy resource. Okay. What low quality means as far as energy goes in environmental science is that it is spread out, it's dispersed, it's diffuse. Quality in environmental science when it comes to energy is how concentrated it is. As we'll see, we apply the same term to matter as into how pure it is of a substance. But in the case of energy, it's how dispersed it is. This is a good thing, actually, because if solar energy was a high-quality type of energy, what would happen when you walk outside? You get roasted by the sun. You would need to have that spread out. It's a huge amount of energy we get from the sun, but it needs to be spread out. And of course, we talked about the fact that our atmosphere The greenhouse effect and all that kind of stuff kind of disperses that in the circulation of the currents and other kinds of things. Helps to reduce the intensity of that. So, if you have a low quality energy source, which means very spread out, you have to collect a lot of it, therefore you would need a very large area typically to get a reasonable amount of power. Okay. And like we were talking about in the pre-response, we're going to continue going over that today. A lot of people will put solar panels on their house, but unless you're very stingy with your electricity, that usually is just a supplement. It's not going to give you enough power. There's not enough area there to actually, to power, air conditioning, TV, all that other kind of stuff, appliances, those kind of things. If you want to have a whole, you want to actually generate a large amount of electricity, you need a lot of land area and things like that, solar farms and that type of thing, to generate an appreciable amount of power. So not only is that a practical issue, but that can also be an environmental issue, because if you're going to put up what they call a solar farm, like a power company would do, it's just going to be solar panels. You can't have woods there, you can't have grass and everything else. It's just going to be covered with solar panels. That's it. All right, and the other big practical disadvantage or practical problem with solar energy is that it is intermittent. So y'all pay close attention, please. Get off your phones. And because this is a very important concept to understand in energy resource management, is the problem with things being intermittent, because this is true of solar. It's also true of wind energy, which are your two big alternative kind of energy types, okay? Which means, intermittent means that it is not constantly available. So obviously, we get sunlight on average how many hours a day?
About 10, 12.
12 is the average. Yeah. So, it does vary, depending upon the season and where you are, but when you average it out, it would be 12. So that means you've got that. You've also got cloudy days. And so that means you're not always going to get enough solar energy to meet your needs typically. So if you have that, if you have an intermittent power supply, if you want power when that power is not there, then you have to store it. You have to save it up. And so that is usually done with batteries. Batteries are not that efficient. Okay, the amount of energy you put into a battery, usually you only get about 30% of that back out. Okay, different batteries, of course, vary. Batteries are typically made of toxic substances. Now, if you're talking about storage for solar systems, they usually use good old-fashioned car batteries because weight is not an issue. When we look at, I'll just get you a second, Mike. When we look at, like Teslas and stuff, and they're developing high-performance cars and everything that run off electricity, they have to have very exotic batteries or lithium-ion and stuff like that, very expensive because weight is an issue. But their lithium-ion battery is not much better efficiency-wise than the lead battery. It's just much, much lighter. And so lead batteries, of course, have lead in them. Lead is a toxic substance. Yeah, come on.
How come on batteries they have the sign that says don't put them in the trash can, but everybody puts them in the trash can anyway?
Are you asking me why everybody puts them in the trash can anyway?
I'm asking why is the symbol there?
Because a lot of them, many of them have toxic substances, and in particular NiCad batteries, which are a common type of rechargeable, although they're becoming less common and lithium ion is becoming more. But cadmium is a toxic heavy metal. So nickel is at large quantities. I don't think they're worried so much about the nickel, it's cadmium typically, which is why they don't want you to throw it in the dump. As we'll learn when we talk about waste management, solid waste management, if you put something in the dump, it can seep down into the aquifer and then get in the water supply and mess up people. Yeah. So just like you don't want to throw anything else that's really toxic into the garbage, same idea there. Batteries is a typical way in which we do it. Capacitors are sometimes used. They're actually more efficient, capacitors are, but they tend to release the energy all at once. So most applications, that's not a good thing for that. This one, hydrogen gas, is, I believe, one of the most compelling, as well as what I think you'll see is the future of electrical storage. And Has anybody ever split water before? Anybody godlike properties and you just go around breaking apart? So have they ever split water before?
I did this thing where like I put my finger in the faucet and it like split it.
Yeah, that's not what I'm talking about. I'm talking about the actual splitting of water molecules into hydrogen and oxygen. Anybody's ever done that? Yeah, Will's done it. Good, good. Lindsay, you done it before? Did you do it in chemistry or just hanging around just through the yeah, you did. It helps. It needs to be. You need to have a little bit of salt in there. Usually, if you're gonna do it like you would do it, we might do it. If you want to bring in some 9-volt batteries, we'll do it in class as an experiment. But I need some 9 volts.
Where do we acquire this from?
9-volt batteries? Same place you get normal batteries, so the square ones.
Is that the trick where like if you have a comb or something, you can like bend the water?
No, I think what you're talking about is refraction, where you show how the light refracts and it makes the water look different there. I don't know what you're talking about, but. I think it's one of the great experiences, so maybe we'll do it anyway. Maybe I'll splurge and buy some on my teacher budget. But if you put electricity in the water, and it needs to have a little bit of salt or something dissolved in it, even tap water, as you know, to conduct electricity. That's why you don't want to drop your hairdryer in the bathtub. But it will split water into hydrogen and oxygen. Okay, so if you have an electrical power supply generated by solar power or windmills or whatever else, and you direct that current into a body of water, it will break that up into hydrogen and oxygen. You'll get little bubbles on the electrodes. I've done this with my grandson. He loves it. He's always asking me if we can do that again. And he knows. He knows what's going on there. He says they're breaking the water molecules apart into hydrogen and oxygen. Hydrogen is a highly flammable gas. So that's a fuel source. So you can generate, you can be producing huge amounts of solar energy, for example, out in the desert somewhere. Use it to break hydrogen apart and then transport that hydrogen to where you need it. You can burn it, and just like you did with fossil fuels, you can generate electricity that way. But one of the even more exciting things about this is the development of hydrogen fuel cells. Now, a fuel cell it's very similar to a battery, except it's like one very big advantage. With batteries, what a battery and both battery and fuel cell are basically compartments where they've got two halves of a reaction, okay? And then when you take and connect the ends, the positive and the negative, through a circuit, you are basically completing those two half reactions. So that reactions are a movement of electrons from one compound to another. So electrons are moving, that's electrical flow. That's how you get energy from a battery. And now rechargeable batteries, when you need to recharge them, because that reaction is, when battery's dead, that means the reaction's gone all the way. With a rechargeable battery, you can put electricity into it and push the reaction back the other way. So it puts the electrons back onto the negative pole, negative pole, the flat side of the battery, and therefore it's ready to go. And then it'll go back through again. Well, as we know, this can be time consuming. Okay, with a fuel cell, you don't have to recharge them. What you do is you refill the chemicals of the reactants. In this case, it's hydrogen and oxygen. So a hydrogen fuel cell has got hydrogen on one side, oxygen on the other side. It completes the circuit of that reaction with, through whatever it is you need to run, your electric motor in your car, whatever else like that. And then what you're done with at the end there is what? What's going to be given off as an exhaust after you react hydrogen and oxygen together. So what you start off with in the first place? React hydrogen and oxygen together, you're going to get water. Okay? So that's its exhaust. So that's good, right? No environmental problems with that. And also, it's a practical benefit because you can do it almost instantaneously. Faster than you can fill a car with gas, you can fill hydrogen fuel cells with hydrogen gas. That's the advantage of fuel cells. They also happen to be more efficient, much more efficient. They're on the order of like 60% efficient. Right now, the only problem is with hydrogen fuel cells is that they require a rare earth element that, as the name implies, is pretty rare and expensive. I think they have to have palladium in them. That's expensive stuff. So right now, the cost is prohibitive on them. Yeah, Lauren, you had
You guys know nothing to do with this, but didn't they come out with they found 5 new elements?
Nope. 3, I think.
3?
I thought it was 3.
I don't know. I just heard that they found more elements to put on the periodic table.
Yeah. Yeah, that was similar. I mean, it's not completely off subject. So, here's the idea here. There's a lot of electrical power sources, like wind and solar, that the best place to collect them is out in the middle of nowhere. And the problem is with now is if you do that, when you transmit electricity through a line, you lose. It gives off energy as it flows along through. It's called line loss. It's basically the resistance. Even though it's a conductor, there's a certain amount of resistance. And the farther you go, the more that resistance takes it out of it. So you could start with a gigawatt on one end and end up with a kilowatt by the time it gets to the house that you're... What? It's a real word. Gigawatt. What's wrong with that? Gigawatt.
What's that?
Gigawatt. So that is, many people believe this is the new wave and the way to store. You can use, and you can use it in cars. If they get the hydrogen fuel cell perfected, they can use it in electric cars, and you'll have performance like you would from an internal combustion engine, and you'll be able to utilize solar and wind energy out in the desert or out in the plains somewhere. You produce hydrogen from it, transport that hydrogen to gas, so you can put out pipelines to transport it in. The only drawback, besides some of the technology still not there yet, is this is a very explosive substance. But you know, gasoline and you know, natural gas are not too great either as far as safety goes. So I think that's a surmountable hurdle. But of course, what most people do when they're using something that's an intermittent power supply is they use it as a supplement. You don't just use that, just like the people putting the panels on their roofs are not relying strictly upon that. You can use it to add to the constant power supply. And what that means, of course, is that granted you're still going to be using perhaps a coal-fired fossil fuel plant to deliver your constant supply, you're going to be using less of it because part of it will be taken up by your solar panels, and of course that's a good thing overall. You're reducing. And we're going to talk about conservation here pretty soon. Any questions?
The noises.
Alrighty.